I thought you were dictating it.
What happens to you? It has general formula like uh that's why I'm checking that uh why you are means why you are not visible to me, because when I start sharing you, your pictures used to came. Okay, so what I'm saying here is that alkenes. So what are alkenes? Alkenes are the compounds of hydrocarbons having, these are the saturated hydrocarbons, means carbon carbon single bond, means carbon 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 single bond. Okay, general formula for them is CnH2n plus 2. CnH2n plus 2. For example, if I ask you to write the formula of hexane, so hexane means 6 carbon, and it should be, the head number of hydrogen should be double of this one, that is 12 plus 2, 14. Okay, whether it is branch, any whether it is a branch or a straight chain, branch, for branch, and straight chain. Put it down fast. These are alkenes.
So done. Done.
Next one is alkene, unsaturated hydrocarbon, unsaturated hydrocarbon with carbon carbon double bond, carbon carbon double bond. Okay, and general formula is
CnH2n.
CnH2n. Like for example, if I have pentene, we will not use pentane, we will use pent for 5 carbon, then E and E, pentene. For pentene, we will have C5H10, C5H10. Got it? C5H10. For C7H14, this is for haptene. Butene is C4H8, butene.
So we just multiplied the number with 2 then.
Now, butene is can mean C4H8 can be the isomers of butene also. Like for example, if I'm writing C double bond C, one carbon here and one carbon here. So this one, or they are in the fourth straight chain, this one, or whether double bond is here, this one, they all going to have C4H8. For example, this carbon has made 2 bonds, so here will be 2 hydrogens. This carbon has made all 4 bonds, 2 here, 2 here, so there will be no hydrogen here. Then CH3, then CH3. So it is formula is 3 hydrogen here, 6 and 2, 8. So this formula is C4H8. Similarly, this one, this carbon has utilized 2 bonds here, so it will be 2 hydrogen here. This has utilized 2 here, 1 here, 3. So only 1 hydrogen, 2 hydrogen, then 3 hydrogen. So 3 and 2, 5, 5 and 6 and 2, 8. So C4H8. The same. Whether you are writing it any form, the formula will be same C4H8. Okay, and there must be a single bond, one single double bond. You cannot have multiple double bond. Like for example, you are having double this one, then single bond and double bond here. No, it is not so. The double bond should be once. Okay, got it. Next one is alkynes. Alkynes are the is also unsaturated hydrocarbons. Alkynes YNE ending with YNE is also unsaturated hydrocarbon. Unsaturated hydrocarbon with carbon carbon triple bond. There should be triple bond between carbon atoms. Okay, we called it alkynes. Like for example, if you are writing, and general formula for this is formula for straight chain or branch. Straight chain or branch is CnH2n minus 2. This time is minus 2. Like for example, if I'm writing C5, then double of this one and then subtract 2. Double of this 5 is 10. 10 minus 2 is 8. C3, then double of this one is 6. 6 minus 2 is 4. C7, double of this one is 14. 14 minus 2 is 12. These are alkynes. Got it? Note it down fast. Done?
Done.
Okay,
So
tell
what
me
is
which of
after general formula?
general formula CnH2n minus 2.
Okay.
Tell me everyone that what is which of the followings, note down this question, which of the followings are alkane, alkene, and alkynes?
First
Which of
one
the
is
following?
alkane.
Okay, second one,
Alkene.
third one,
Alkyne.
okay. Means where it is exactly double, so means double bond is there. Double bond means ene. And if it is greater than alkane, if it is less than double, then it is alkyne. Okay. So this is alkane, this is alkene, this one is alkyne, this one. Tell
Alkene.
me this.
Alkene.
Alkene, this one.
Alkene.
Alkene, this one.
Alkene.
Alkyne.
Alkane. Alkane. This one is alkane. 9 to the 18 plus 2. Alkane. This one.
Alkene.
Alkene. This one.
Alkyne.
Why alkyne?
Because it is more than 14.
So this is alkane.
Oh,
Wine is less.
my bad. Yeah, sorry.
This one.
Alkyne.
Alkyne.
Yeah,
This one.
alkyne.
Alkyne. So note this answers. Okay. And just write the double bond and triple bond between them. What is it? Okay. Like this. Just a minute. Write down this one and write down which is alkene. Write single bond. You done this one? Noted? Noted?
Yeah.
It is also important that homologous series. Note it down, everyone. Homologous series is the we'll simply say that when we are talking about the homologous series means a group of hydrocarbons or the compounds of hydrocarbons in which the successive or the previous member, which the successive or the previous members is differ by CH2 group. CH2 group. What is CH2 group? Let me explain you. Like for example, if I'm writing here, this one is okay. This one is CH3 CH2OH. This is ethanol. You can write it C2H5OH. You can write it like this way. Okay. So if you are having this ethanol and this ethanol, if I asked you to write the next homologue of this one, so that will be increase one carbon C3 and two hydrogens C3S7OH. So these two are the homologue. Homologue. Got it? Homologue of alcohol. Got it? So if I'm writing like for example C3S6, so I ask you that what is the next homologue of this one? What is the
C4
ne
C4H8.
H8? If I write C3H 8 C3H8 then it will
C4H.
C4H10. Okay, so this will be the formula. But this one and this one is not considered to be as homologue because it is not having CH2 group as. So these two are not homologue. Not homologue. Got it? Because they are having only one carbon difference, hydrogen is same. So whether it is any alkene will be alkene, alkane will be having next homologue in the alkane. Okay, so homologue, the two homologue must have CH2 group difference. Got it? And they must have same functional group. So everybody noted down the compounds of hydrocarbon with the successive member is differ by CH2 group. Such compounds are called homologue and the series is called homologous series. Note the homologue must have same functional group. The two member with CH2 group difference but having different functional group will not be considered as homologue. Means if we have two members, let I'm going to explain it, but first you note it down.
So done.
Okay. Next is this one. So what I'm going to explain you here is that functional group. What I'm saying that the two homologue must have same functional group. This means that, for example, even if I'm writing that ketone and aldehyde, like ketone is C3H6O. This is the compressed formula for ketone and aldehyde. Okay. Like if someone is saying that it is a ketone, and the one is saying that C4H8O, it is an aldehyde. Are they considered to be as functional group? Sorry, homologue. They are having CH2 group difference, one carbon and two hydrogen. Ibad, are you doing something else? Ibad, it seems that you are doing something else. Show me your copy, please. I think that you are doing continuously something different.
Yeah, I'm
So
writing the thing you told.
just a minute.
I'm writing now.
Sure. Show me your previous copy. Show me the previous one. Previous page.
One second.
So even if I'm saying that this is the ketone or this is an aldehyde. Okay. So like ketone is CH3, C double bond O and then CH3. You know the condition for ketone? That ketone must have carbon on either sides. And for aldehyde, we have CH3. For four carbons, aldehyde is CH3, CH2, C double bond OH. Aldehyde group is generally used on the terminal carbon, last carbon or the first carbon. Okay. So this is considered to be as aldehyde group. Now, if you count the total carbon are 3, hydrogen is 6, and then 1 oxygen. Oh, and here is carbon is 4. 1, 2, 3, 4. Hydrogen, if you count it, it will be 8. 3, 2, 5, 2, 7, and 1, 8. And then 1 oxygen is O. So they both are having CH2 group difference, but since they are having different functional group, they will not be considered as homologue. Homologous, even if simply you can say that, for example, if I'm saying that like cyclobutane is this one. This is cyclobutane. Okay. And this is cyclobutane, which is having cyclo. If you counted, the general formula for this one will be C4H, but since it is cyclo, it is not a straight chain. So there will be 2 hydrogen less. Because if it is open chain, then you remove this one. Now it is open chain. 1, 2, 3, 4. And here the terminal carbon will have 1 more hydrogen and 1 more hydrogen here. But since they are making bond, it is cyclo, so they both are making bond. So formula will be C4H8. And this same formula can also be, for example, if I'm asking for the butene. Okay, the same formula will be C4H8 will be for the butene. In a straight chain, it will be for butene. Okay, because this central carbon has utilized 3 bonds here, so 1 hydrogen will be attached here. It is also 1 hydrogen will be attached here. So this is butene, C4H8. Got it? Understood? Yes or no?
Yes.
Yes, sir.
Yes.
Now talking here is this one, that this one is C4H8 and this one is C4H8. Now moving here is one thing that you need to understand. Okay. That C4H8. Okay, now coming to the point, here is C4H8. And if I'm making like propene can be like this one. Propene can be this one. Okay, they are having, no, this is 1 hydrogen, 3 hydrogen at the top terminal. This carbon has made 3 bonds, so it will be 1. This carbon has made 2 bonds, so 2 bonds. If you count, it will be C3S6. This is C3S6 compressed formula, and this is C4H8 for the cyclobutane. So both are not homologue. They are not homologue. Because it is having double bond, it is double bond and single bond is also treated as a functional group. Double bond and single bonds are also treated as functional group. Okay. So if one is having double bond, other one is having single bond, so they will not be treated as homologue. Even if they cyclobutane and normal propene, they both have CH2 group difference. It is having one carbon and two hydrogen difference. So if it is cyclo, the next will be also cyclo. For example, the next homologue of cyclobutane will be C5H10. C5H10. This is the next homologue. This is this will be cyclopentane. Cyclopentane. And this same formula can also be for pentene. C5H10 can also be pentene, which is having its double bond. So this is pentene. If I ask you the next homologue of this one, it will be C6H10 and it will be hexene. The names should be written as hexene. Got it? Understood? Functional group
Yeah.
here, it is also having ene, it is also having ene. So both are going to have the same functional group. If I'm saying that propanol, propanone means ketone. So if I ask you the next homologue of propanone, so the formula for this one will be C3H6O. The next homologue of this one will be butanone. The both must have same functional group. This will be C4H8O. If I said that butanol will also have the same compressed formula, C4H8O. But propanone and butanol are not homologue. These two are homologue. Understood? Understood? Got it?
Yes, sir.
Next one. Now moving to the noted down chemical properties of hydrocarbons. Write down topic chemical properties of hydrocarbon. Write down the chemical properties of alcohol. First, we're going to study the properties of alcohol. Chemical properties of alcohol. Alcohol means only ethanol, especially because ethanol we're going to study in our syllabus. Okay. So, Maha, that write the topic that in the next class I need to teach. Okay, write down that I have to teach combustion reactions. Note it down. Combustion reactions. Means combustion of hydrocarbon. Combustion of hydrocarbon, comma, preparation of alcohols. Preparation of alcohol, comma, saturated and unsaturated hydrocarbons. Comma, saturated and unsaturated hydrocarbons. And uses of alcohol. And uses of alcohol. This I have to teach you in the next class. Okay. Uses of alcohols. Okay. So we are just going to discuss is chemical properties of alcohols. Chemical properties of alcohol, especially ethanol, we are going to have in our syllabus. Ethanol. Okay. So ethanol is C2H5OH. It can be written like this, or it can be written like this: CH3CH2OH. This is ethanol. Okay. Got it? Now if I'm having CH3, CH2, and then OH. plus, so first of all, if we burn it, combustion, if we burn it in the presence of oxygen, this is called combustion. Then it will simply gives you carbon dioxide and water. This is the simple property, carbon dioxide and water. The second property is oxidation of alcohol. Any hydrocarbon, if you burn it, it will give you carbon dioxide and water. Not only the alcohol is going to give you. Any alcohol, any alkane, alkynes, okay? Any aldehyde, any compound of hydrocarbon, if you are burning, it will give you carbon dioxide and water. Okay? And this is called combustion reaction. This is called combustion reaction. Next one is, if I'm talking about the oxidation. Oxidation means addition of oxygen or removal of hydrogen that you have been studying in the first chapter. So if you take the ethanol, C2H5OH especially, okay, and then you keep it in the presence of a reagent, an oxidizing agent that we called it. Just leave the space here, okay? Just leave the space here. I'm just writing here something, okay? Acidified KMNO4 or alkaline KMNO4 or acidified potassium dichromate. Alkaline KMNO4 or acidified potassium dichromate K2Cr2O7. K2Cr2O7. Okay. So the ethanol or alcohol in the complete combustion will get converted into ethanoic acid. Means it will get converted into ethanoic acid, CH3COOH plus water. Now the general reaction, if I write for the oxidation of alcohol, okay, for the oxidation of alcohol, if I'm just writing the general reactions, okay, that is when alcohol is oxidized in the presence of any one of them, alkaline KMNO4 or acidified potassium dichromate, they will give you carboxylic acid plus water. And the same number of carboxylic acid you will get. You will get the same number. For example, if I'm talking here is that, if I'm talking for the alcohols, okay, if I'm talking for the alcohols, for example, if you have 2 carbon alcohol is ethanol, so you will get ethanoic acid as a carboxylic acid. If you have propanol, you will get propanoic acid for the 3 carbon carboxylic acid. If you have 5 carbon alcohol, pentanol, then you will get pentanoic acid. Got it? Got it? Everyone understood? Oxidation of alcohol.
Yeah.
And here the oxygen you will get for this one is in the form of nascent oxygen. It will not be in the molecular form. You write 2O. It is in the nascent oxygen. It is called nascent. It is not O2. You get oxygen here by in the nascent form. Nascent form means nascent oxygen. Note it down, nascent oxygen.
What does nascent mean though?
Nascent means that it is the oxygen which is not in the molecular form. It is obtained from some. It is not obtained from the atmosphere. It is obtained from some atmospheric, not from the atmospheric oxygen. It is from the compound that is giving you. Aisha, क्या कह रही थी बेटा? What are you saying?
Nothing.
Okay. So any alcohol, okay. If it is C2H5, we complete oxidation is done, then you will get this one. And same alcohol, if you have H2SO4 or sodium dichromate, it is an incomplete oxidation, we call it, and then will give you the same aldehyde. It will give you aldehyde. CH3CHO, the 2 carbon aldehyde. So if you are changing, if it is having alkaline KMNO4, then it will give you carboxylic acid and water. And if you are having different reagent H2SO4 and sodium dichromate, then it will gives you incomplete oxidation will be done, and it will be considered as, it will give you aldehyde. Put it down fast. Same number of carbon, you have to keep in mind that if you Noted?
No, sir.
Is Harshit is there? Harshit,
Yes, sir.
are you getting better?
Yes, sir.
So you done this one?
Yes.
Yes, sir.
Now, beta, just concentrate here, very important, okay? Ethanol or any alcohols, like for example, if I ask you how will you get uh, pentanoic acid from pentanol? How will you get pentanoic acid from pentanol?
By heating,
By treating it with alkaline KMnO4 or acidified potassium dichromate. Okay, got it?
Hmm.
Uh, just propanol to propanoic acid mean alkaline KMnO4s. Okay, so this is an NCERT questions. Just what's the time right now? 13 minutes remaining. Okay. Like if I ask you that why this conversion of ethanol to ethanoic acid is considered to be an oxidation reaction. It is an oxidation reaction, not combustion. Why we are saying it is an oxidation? Because in this process, addition of oxygen, removal of hydrogen is taking place. How many hydrogen atoms are there in this ethanol? Total 6.
Hmm.
And how many are there in the ethanoic acid? 4.
Yeah.
And how many oxygens are there in this one? 1. Ethanol 1. And how many are there? 2.
2.
Simple that since in this process addition of oxygen and removal of hydrogen is taking place, that's why it is considered to be as oxidation reaction. Okay, will you able to write this answer properly? Dekh loge sab? It is simple. Should I
yes,
should I jump to the next topic?
yes,
Take the screenshot of this one. Take the screenshot. We'll give you this one in the homework. Done.
Yes.
Yeah.
Okay,
Yes.
now here the color change is important, that the purple color alkaline KMnO4 is in purple color. So, and it is also called Bayer's reagent. It is also called Bayer's reagent. Okay. And okay, so when you are adding this one, ethanol to ethanoic acid, it act is a strong oxidizing agent and its color changes. Its color changes. So its purple color changes to, means purple color will disappear. Here it is also acidified potassium dichromate is green in color, its color also disappears. So the color disappear. So they are not treated as a catalyst, because if something color is changed, so it means it is being utilized in the reaction. Okay. Otherwise, after the conversion of ethanol to ethanoic acid, the color should remain if it is acting as a catalyst. Okay. So it is not acting as a catalyst. It is acting as a strong oxidizing agent. Okay. So notice down here that alkaline KMnO4 is used as a strong oxidizing agent, not as catalyst. Alkaline KMnO4 is used as a strong oxidizing agent, not as catalyst. Not as catalyst.
Done.
Done, everyone? And here its color changes to purple, purple to colorless, and here it is also greenish, greenish to colorless, So potassium dichromate is green in color, so its color will change from green to colorless. Okay, so any one of them which are using, mostly is alkaline caminophore is used, and it is called Bayer's reagents. It is called Bayer's reagent. Bayer's reagent. Alkaline caminophore is called Bayer's reagent. Okay, done. Should I move to the next property? Done, everyone? Abdul Kavi,
Yes.
you used to leave the class, huh? Every time 10 to 15 minutes earlier. Okay, I was noticing you in every classes. Okay, I'm just noting you. Everyone, it should be a discipline. Everyone should have to maintain the discipline in the class. Okay, if anyone I found that he's leaving the class without informing me, okay, if it is network issue, let it be. I don't care whether it is a network issue or something else. Anyone, if I found and he left the class without informing me, then he must be, okay, he must be given some extra treatment in the next class. Don't worry. So please be here for the whole time the teacher, unless and until I told you that the class is over, and that's all for today. Okay, that unless and until I told you. Next one, if
Sir?
I'm talking, yes.
What's that PD, PT and everything that you wrote?
Where I wrote PT. That is something else. That is not here. That is something else. Okay. So what I ask you that, if I ask you that, what does alcohol give on complete oxidation? What does alcohol gives on complete oxidation? Tell me, Alvina. Alvina and Ayan, tell me, what does alcohol gives on complete oxidation in the presence of alkaline caminophore? Tell me. Yes, you, Gianna? Aisha? Beta, what
Sir,
will
I didn't understand your question.
I'm saying that what does alcohols give on complete oxidation in with alkaline caminophore?
Carboxylic acid.
Yes, they give carboxylic acid.
Yes.
Now alcohol, if the alcohol is of 2 carbon like ethanol, then it will give you ethanoic acid. If alcohol is of 3 carbon like propanol, then it will give you propanoic acid. Got it? So the number of alcohol, number of carbon of alcohol you are using, you will get the same number of carboxylic acid. Got it? Is that clear?
Yes, sir.
Okay.
Yes.
Next, moving to the next part here is, don't get confused here. Most of the students use write C2H5 then COH. They will write here C2H5 then COH. If you write it, it will be 3 carbon carboxylic acid, not the 2 carbon carboxylic acid. So it will be correct as considered as incorrect. If it is 2 carbon, then here should be 2 carbon, including the functional group carbon. Okay. Now moving to the next one is, next property of alcohol is, alcohols when react with metals, they gives you metal oxides, salt plus hydrogen gas. Alcohols on reaction with metals, especially highly reactive metal like sodium, it will gives you salt plus hydrogen gas. And can you tell me that what is the name of this one? If it is alcohol, if I'm talking here, just a minute. If it is alcohol, when react, like for example, if I'm writing C2H5OH, if you reacted with sodium, it will gives you C2H5ONA plus hydrogen gas. And the name of this compound is ethyl sodium ethanoate. Sodium ethoxide. Sodium ethoxide. Ethoxide. Note it down. Sodium ethoxide. Ethoxide. And this alcohol here. The alcohol is showing the property similar to acids. Here, the alcohol is showing the property similar to acids. Similar to acids, but still it is not characterized as acid. Why? Discuss in chapter 2. Why ethanol or any alcohol is not characterized as acid? Like for example, acids when react with metal, they form salt plus hydrogen gas. Same alcohols is also reacting with metal, they are also producing the salt plus hydrogen gas. But still ethanol is not considered, or any alcohol is not considered to be as acid. Why? They don't turn blue, it must to red. Why? Can anybody answer me this question?
They don't give out H plus ion.
Yes, when you are adding this into water, they don't give H plus ions.
So done.
Done, sir. Same.
Okay. So a reason is that they don't dissociate H plus ions in aqua, so that's why they are not characterized as acid. Okay, got it? Next property, the very important property, very important, that is esterification. 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 Alcohols when react with alcohol when react with what? Carboxylic acid. Then it will gives you alcohol when react with carboxylic acid, then it will gives you esters, sweet smelling substance ester plus water in the presence of concentrated H2SO4.
So done.
Okay, now if I'm having alcohols. Okay, now what is alcohol? Like for example, C2H5, if I took C2H5, and this is carboxylic acid is CS3COH. Got it? If I write it concentrated H2SO4 here, then it will gives you what it will gives you. This first tell me what is ester. Ester is like ketone is C double bond O. This is ketone, and here is R group. What is R? What is R? R is actually carbon chain. R is actually carbon chain. So if it is having CH3 or CH3, then it is ketone. But if I having C double bond O and this C, this is a group of ester. This is ester group. Here it is R, here it is also R. So this is ester. C double bond O and O. This is ester. So here one R come from alcohol, and one R come from carboxylic acid. And an ester must contain exactly the same number of carbon as that is present in total in alcohol plus carboxylic acid. For example, 2 carbon alcohol react with 3 carbon carboxylic acid. Then this whole ester will have 5 carbon total, including the functional group carbon. Got it? Got it?
Yeah.
Yeah.
For example, if I say here that this is 3 carbon alcohol and 2 carbon carboxylic acid, then how many carbon alcohol will be there? Tell me fast. 2 plus 3 is 5. Simple. The total number of carbon you will get from this one. Got it? So here, if I'm having this one, so first we will write this one CH3 COO, and then we will add this one. This one will be C2H5. Got it? Plus water. And the name of this compound will be, we'll write the name of this compound which is attached with the double C double bond O. Okay. We will write the name of this one. What is the name of C2H5? What is the name of C2H5?
Ethanol.
Ethyl. C2H5 is ethyl. C2H5 is ethyl. Okay. So the name of this compound will be ethyl. Ethyl for this one. And this is the 2 carbon. So we will use eth, carbon single bond N, and the C double bond O is O8. For ester group, we use O8. Suffix for ester group is O8. Ethyl ethanoate. Note it down. Ethyl ethanoate. Done? Noted?
Done.
How many carbon do we get from the alcohol here? 2 carbon. That is C2H5. And 2 carbon from this carboxylic acid. Okay? Got it? Got it, everyone?
Yes.
Yeah.
Okay. Now this is C2H5. The total number of carbon is 4. Okay. If I write the compressed formula for ester, just concentrate here, but everyone, everyone concentrate here. That is C4, double of this one 8, and then O2. It is the compressed formula. That is CnH2n and O2. And this is the same formula for carboxylic acid and ester both. Like ester, sorry.